Welcome to Data Protection Gumbo, episode 24, and I am your host, Demetrius Malbrough, your Chief Data Protection Chef. And today, we are starting with part 2 of a 3-part series with Datos.io, where we will explore scale-out, non-relational databases in depth. And Datos.io solves new data management challenges for cloud and big data databases, so that enterprises can confidently deploy and scale their applications without worrying about data loss. And today we are joined by Jeannie Liou, Product Marketing Manager at Datos.io, Shalabh Goyal, Product Manager at Datos.io, and a very special guest, Jeff Marinstein.
Thanks, Demetrius. I wanted to quickly introduce Jeff Marinstein, who we are fortunate to have join us today. Jeff is an industry veteran, having shaped IBM's entry into the SaaS storage business and the transformation of IBM's DR business into the cloud. He will cover some of the things he's learned along the way in helping make enterprises more resilient to disaster scenarios, and will share best practices for those listening.
Okay, fantastic. So we're going to pick on Jeff first here. So Jeff, can you please share your perspective on how the IT industry is changing?
Hi Demetrius, thanks for having me on your podcast. That question's a great lead into our discussion today about data protection and disaster recovery. Since the mid-90s, the IT industry has been going through a major re-platforming event characterized by cloud, mobile computing, social computing, and big data. There are different ways we could describe the evolution of the technology industry. For example, we could talk about the types of computers and applications, but let's focus today on the relationship between computers and users. Back during the mainframe era, one computer would support thousands of users. As we moved into the PC era, we saw a single computer supporting just a single user. Today, we find ourselves in the mobility era, where several computers, for example, our smartphone, a laptop, a tablet, perhaps a device like a fitness tracker, all share information in support of a single individual. And we're headed into an era which maybe we'll call the ubiquity era, where hundreds or perhaps thousands of devices, all connected through the Internet of Things, will support just a single individual. As users, devices, and data continue to move further away from the traditional data center, big tech companies such as IBM, Hewlett-Packard, and Dell have continued to struggle. These traditional stack vendors are being challenged by the evolution of cloud services and new solutions where speed and agility rule the day. We're seeing companies move from on-premise data centers, once considered the workhorse of corporate IT, to borderless cloud solutions delivered via mobility. Data is the new natural resource. We're producing volumes of new data at rates never seen before in the IT industry, and the companies that master distributed computing and transform this massive data into knowledge will set themselves up for a very bright future.
Wow, that is fantastic, Jeff. So I really like that statement. The data center has become the workhorse. Ubiquity era, and thousands of computers are being shared for one user. So that is definitely a fantastic way of looking at it. So how prepared are enterprises to handle some of these changes that you've mentioned?
Well, it depends on the size of the business. The companies I talk to are trying to acquire the types of skills needed to make this transformation and adjust to new ways of developing products and services. Things like DevOps, cybersecurity, agile development, data analytics are all critical new functions and require new skills. Many companies have begun this journey, but they're still years away from being digital enterprises. One clear indicator of progress we see is that over 90% of all new applications are being developed for the cloud. These cloud applications have very different design characteristics than traditional monolithic systems, a topic, by the way, I see you're already discussing in your podcast series. Digital transformation is affecting almost every aspect of society. Companies are using the data they collect to build closer relationships with their customers, provide new services. Think of Uber or Airbnb. Digital government initiatives are making the lives of citizens easier. And the medical field is transforming healthcare using data and analytics to improve treatments and enhanced patient experience. But this journey isn't easy, and the changes are highly disruptive. Digital transformations affecting all aspects of an organization, from its business processes to its ecosystem, its business model, and even the assets the business owns. Today, in many cases, value creation comes less from tangible assets and more from the value a company can gain from its data. Priceline is worth $61 billion, and it doesn't own an airplane, a car, or a hotel room. It simply offers a service to consumers based on data it collects. We're seeing medium and large enterprises invest in the key elements of digital transformation: cloud, mobile, social, and big data. By the end of 2017, about 2/3 of the Global 2000 CEOs say that digital transformation will be at the center of their corporate strategy. That's exciting to hear because this type of change has to be led from the top of the organization. I'm sure IT will look different 10 years from today. Buckle your seatbelt. It's going to be a fast-paced, fun ride.
Yeah, absolutely, and this is definitely an election year, so a lot of changes are on the way, and not only are the large enterprise companies kind of being downplayed for commodity hardware. It's definitely a buckle your seatbelt moment. So we are going to move into, virtualization and cloud full steam ahead, definitely. So, Jeff, so what does it mean for, data protection and also disaster recovery, needs that customers and companies, are going to need, since this data, just has exploded and we have open source and open stack now?
It means an awful lot, and I'll tell you why. Let's look at where we've come from and where we're headed. For the past 25 years, disaster recovery has been oriented mainly around infrastructure to protect monolithic applications. As long as you provide like-for-like infrastructure and have good backups of your data, you can have effective disaster recovery. DR is fairly expensive, so we have to prioritize which applications to protect. But BCDR methods have proven effective when DR can be bolted onto the back of an application after it's been deployed. The tools and data centers that provide this type of data protection were built over 20 years ago. They work well for legacy environments and systems of record, but weren't designed for today's systems of engagement. The use of cloud computing has offered some relief in the form of lower cost infrastructure, and virtualization has removed the requirement for like infrastructure, so DR has made progress in the past 5 years. DRaaS solutions have helped us use the cloud as a landing zone for data protection and recovery workloads, but not yet at scale, and I see this as a problem. But now we're seeing a need for new solutions to support cloud-native applications. This is where our industry is headed, so let's talk about some of the key needs. The first is resilience. Companies today tell us that they have almost no tolerance for downtime. If a web service is not available, well, 2 clicks and you're fired. Data protection and DR have to ensure that applications are always available. These cloud-native applications are different. They use distributed databases that can scale out to hundreds or thousands of nodes. We need a new generation of data protection and orchestration software to provide resilience for these type of applications. Yesterday's backup and DR tools weren't designed to provide application-consistent resilience for cloud-native apps. So cloud resilience, almost by definition, will have to be tied to the application and provide scalability from both a cost and performance perspective and ease of use. This means that DR practitioners will have to adapt to the DevOps model, and their needs for data go beyond secondary copies for DR. We're seeing next-generation tools evolve to support a wider array of use cases for secondary data, including test and development support, cloud migration, and analytics. Disaster recovery and data protection professionals will need to learn new skills, for example, understanding how NoSQL databases work, how to optimize cloud costs, and new methods for protecting data. I expect we'll see IT disaster recovery reshaped quite dramatically over the next 10 years. And the last point I'd make is that we'll see disaster recovery and data protection more tightly integrated with risk management. The most common outages we see today are caused by human error, cyber risk, and software errors. 20 years ago, security risks caused isolated problems. Today, the Sony cyber hack, for example, took down an entire company for a period of time. The computing landscape and the threat landscape have changed, and we're beginning to see the role of disaster recovery and data protection change with it.
Very interesting. So, I guess what are some emerging data protection and disaster recovery capabilities that are needed for today's data-centric world?
Well, I think we first have to address the sort of cloud-native myth that the cloud-native people propagate, that resilience is an inherent attribute of cloud and that disaster recovery is obsolete. I wouldn't be surprised if Shalabh and Jeannie and other people haven't talked to some people who've said, the cloud will just handle all that. It's not necessarily going to be provided through third-party solutions. I don't believe that that's true. I think disaster recovery will always be needed for mission-critical applications. Every major cloud provider, including some of the not-so-major cloud providers, have all suffered multiple outages. And while there is some level of truth to the fact that the cloud has a design principle that everything will fail, it is still and will always, in my opinion, be the responsibility of companies to protect critical information. It's a governance requirement. Disaster recovery and the ability to bring back those applications within the appropriate amount of time will still be something that companies need to handle. They won't simply be able to host an application in the public cloud and imagine that all that is handled, in the course of a contract. They still can't buy cloud services with SLAs that guarantee them zero downtime. And so I think you're going to see and are seeing new vendors, companies like Datos, with technologies to address really key issues such as scalable data protection in the distributed world, disaster recovery at scale for NoSQL databases. I think you'll also see that there is a tremendous need to deal better than we do today and provide management of disaster recovery and data protection in a hybrid environment where a combination of public and private compute resources exist and probably will exist for many years to come. I've talked with a lot of CIOs that don't know what disaster recovery is frankly costing them. Or I also think, and I've started to write about this and talk a little bit about it, I think as workloads and data begin to move into the cloud stack, and recovery times and recovery points, shrink to the point where we use the word resilience, meaning things just don't fail. There will be both the need and opportunities for predictive analytics to improve the world of resilience. It will be harder for humans to react to ultra-low RTO and RPO needs at global scale without some help. Today when we have perfect weather data that tells us a hurricane is coming up the coast and we have to move workloads from data center A to a service provider or to another data center that we control. People know how to do that. But I think in a world where the threat landscape includes cyber attacks and more human and software-induced errors than simply natural disasters coming from hurricanes or power outages, we will need to provide automated help through advanced analytics to help people keep up with all this. So I see a world in which we will augment basic tools that we find in open source databases that lack enterprise class disaster recovery. I mean, it took relational database vendors many, many years to build robustness into their products to be able to have application specific and application consistent copies of their databases replicated to be used for disaster recovery. Many open source projects today lack that tooling, and you see companies like Datos stepping in to provide these solutions. It's really a world, Demetrius, where disaster recovery will become enabled through intelligent software. I think if I had my crystal ball, I would tell you that legacy disaster recovery will continue to shrink. It'll be a niche business, either for applications that can't be cloud-enabled or for companies that just are not on the cutting edge of technology. I think it's a world in which application-centric vendors, perhaps companies like an Oracle or others that have deep application expertise and are investing in cloud and resilience, may emerge as newer players. The bottom line, I think you'll see application-oriented disaster recovery and data protection, analytics, and risk management grow. Cloud will become the de facto landing zone for workloads, and traditional disaster recovery and data protection that we've come to know and rely on over the last 20 years will begin to fade out as a business.
Well, just to add to what Jeff mentioned, I completely agree that the applications really drive the infrastructure and the software stack. If you look at new applications, like Jeff mentioned, they are scale out in nature, and most of them, 90% of them, are deployed in cloud. So the key requirements for these applications, if you think about it, are availability, scalability, and agility. I want my application to scale quickly, I want it to be available, and I want it to be agile. So most of these applications are now deployed on next generation databases, scale out databases that are distributed in nature. And it's hard for the legacy data protection products to evolve for this environment. I mean, if we look at these data protection products, they were architected 20 years back for the client and server era and monolithic applications. So at this point, I think we need a new architecture that is built to tackle the unique challenges of protecting distributed databases.
Great. So, Jeff and Shalabh, you guys are taking up all the airtime from Jeannie. I'm going to have to hear from Jeannie now. So I guess, how does Datosio fit in the data-centric world? And what do you offer?
Absolutely, Demetrius. We see that there are many innovations happening in social, mobile, and cloud. And as a result, enterprises are increasingly relying on next-generation applications. And these applications are IoT, analytics, and security, and they're using this mainly for business growth. What we offer today is backup and recovery for these next-generation databases, such as Apache Cassandra, DataStax Enterprise, and MongoDB. These are the databases that support these scale-out. These are scale-out databases that support these next-generation applications. So to really get at the heart of the problem we solve, it's truly recovering from data loss in next-generation databases, both at speed and scale. So as Jeff mentioned previously, traditional disaster recovery and data protection methods don't work, and they don't respond well to the cloud distributed needs. And the other point that he mentioned, which was very interesting, is that disaster recovery will have to be application-oriented to achieve scalability. And so what we do is we offer application developers, application architects, three things. One is to reduce downtime. So we reduce downtime by achieving recovery in minutes and not hours. We help save on secondary storage costs by up to 70%, and we help increase productivity of application and DevOps teams.
Okay, so Jeannie, you talked about next-generation databases. So can you please clarify for me what you mean by next-generation databases?
When we say next-generation databases, they have three main characteristics. One is they scale up horizontally. So if you want to get higher performance, you just add another piece of similar hardware. It's different from relational databases where they are designed to run on a single machine, so to scale you buy a bigger machine. The second is they're deployed mostly on commodity hardware and are distributed in nature. And the third is they generally offer tunable consistency, which is the ability for application developers to tune consistency depending on the requirements for response time versus accuracy, which goes to our college and university days of CAP theorem. When we talk about consistency, availability, and partition tolerance, it's impossible for a distributed computer system to simultaneously provide all three. So there has to be trade-offs made. In terms of data models, some of them are document-based, such as MongoDB, CouchDB, Microsoft Azure DocumentDB. Others are based on column family models, such as Apache Cassandra, Google Bigtable, and Apache HBase. And then finally, you have graph databases, which which you find have a very common use case around social networking. They'll show you your connections and sort of provide the network effect for social media.
Okay, great. So that makes sense now. I understand next generation databases. Shalabh, so as we are on this subject of next generation databases, can you tell us what is really technical about and also challenging in the backup of scale-out databases?
Well, sure. So scale-out databases are fundamentally different from the scale-up databases or relational databases like Oracle, MS SQL Server, MySQL, and Postgres. And that translates into some of the challenges when we do backup of these distributed databases. One of the technically challenging thing is to generate a consistent copy of a database across the cluster. In a traditional database, you're running on a single set of hardware, you QoS that, and you take a consistent copy of backup. That is not possible in a scale-out database. It's especially difficult because they are distributed in nature and their eventual consistency model, as Jeannie just talked about. So let's assume a scenario where an application that I'm running on this scale-out database, it has issued a write that has persisted on one of the nodes, but it's still in flight and has not replicated yet to the other nodes. So if my application uses majority consistency, which a lot of applications use, that write is not acknowledged back to the application. Now, at that time, if I take a snapshot of all the nodes, which is a traditional way of doing a backup, then that write has not persisted on all the nodes, and I will get a non-durable write. And there will be several such writes that have not reached a durable state, but now become a part of my backup copy. So when I restore this backup copy, these non-durable writes are restored as well. So why do I care? Well, this really means that if I have to restore my data back, after I restore the data back, I have to run this time-consuming repairs on my database cluster to bring that cluster back in consistent state. Because when I took the backup, the nodes were not in consistent state, and I captured a lot of writes that were not durable. By the way, any of these repairs that I run after the restore can run into hours and days, and that really adds to the application downtime. And if the application is down for a long time, I'm suffering on my business. On my revenue opportunity, I'm losing customers. One other artifact of this is it can create a situation where I'm reintroducing a transaction that was never acknowledged to the application in the first place, because when I took my snapshot, it was just persisted on one node rather than the majority or the quorum consistency of the nodes. So all these technical challenges, they add up, and it makes it really challenging from the backup perspective to take a durable copy of the backup for these scale-out databases.
Okay, great. So I guess I am still kind of a dinosaur, and I haven't backed up a scale-out database yet, such as MongoDB or CouchDB. I'm still really trying to wrap my mind around the names of these databases. They're kind of funny to me, but most important question here. So what are the benefits that Datos IO Solutions brings for the customers?
Sure. So I think Datos IO realized upfront that this transition is happening in terms of the applications, in terms of the databases on which these applications are deployed. And we started building a new architecture for your data protection from ground up, specifically designed for distributed and cloud databases. So some of the attributes of this architecture and this product that we have from Datos IO for data protection are that the software itself, the Datos IO software, scales out with the application needs. So you may deploy it in a single node configuration or a 3-node configuration, and as your requirements of the applications and database increase, you can increase the Datos IO footprint as well to tackle the challenge of scale. Second, we solve the consistency problem. So rather than taking node by node snapshots and trying to make sense out of it when we restore it back, we take a cluster-wide consistent snapshot of your database. That means only the writes that have persisted on majority of the nodes are recorded during the backup. There are no repairs, so when you restore your application or when you restore the data, your application downtime is minimized. Then we only store one copy of the data rather than storing multiple replicas of this data, and we save on the secondary storage cost. And finally, we built an orchestrated restore or orchestrated recovery engine that does extremely fast restores back into your running database. So no repairs, no hassle, and very short time to recovery. But I think I missed one other important aspect, which I think is easy to miss if you don't see it through, and that is resiliency to the failures. Now in this new world, we are not talking about a golden Oracle database with all sorts of resiliency built into the nodes or the hardware. In this world, the nodes or the databases are deployed on commodity hardware, and they are deployed in a way that failure is a norm. So it's very important for a software that does data protection of a database to be resilient to such failures. So Datos.io is architected in a way that we are not only resilient to the system process or the node failures on which Datos.io is running, but we are also resilient to the failures of the database itself. So we understand that nodes will fail, and we still have to continue taking the backups and continue providing enterprise class data protection for the databases. All in all, as Jeannie mentioned, it results in significant storage cost savings, a lot of operational efficiency in the data protection and recovery, and much faster recovery, so less application downtime.
Great. Well, this was all fantastic information, and we are just about out of time. And I really appreciate you guys appearing on Data Protection Gumbo. It was a pleasure, and we will see you in part 3 very, very soon. Thank you. Thank you so much for listening to Data Protection Gumbo, and you can check us out at dataprotectiongumbo.com, iTunes, or just Google us. You can also follow me on Twitter at dmalbro, and you can connect with me on LinkedIn. And also, I am proud to announce that we have now reached over 10,000 hits a month on the website. So thanks to all of the listeners, fans, and the feedback that you have been providing me, which has helped me improve the show tremendously. Thanks again, and see you next time. Have a great week.